So today is all about applications, so word problems. All right, jump right into it. There's no new strategy to it. It's just taking a word problem, pulling out that key information, creating equations, and solving those equations. Okay, all right. So this one, I mean, you can write down the whole setup to it, or you can just write down the math and go back if you want. I mean, there's a lot of words, but there's only key stuff that we're going to pull out of this. 2015, the average of the median salaries of an accountant in San Diego and Salt Lake City was $47,449.50. The median salary in San Diego was $5,333 more than Salt Lake City. Determine the median salary for an accountant in San Diego and Salt Lake City. So, with these word problems, first step is identify some variables or assign some variables of what you're trying to find. All right, so I'm going to say X is going to represent San Diego, and I'll say Y is going to represent Salt Lake City. All right, that's what we're trying to figure out, what the median salaries are for those two. The first sentence, in 2015, the average of the salaries in San Diego and Salt Lake City was $47,000. So I know the average of these two. So if I think of X plus Y divided by 2, that's the average of the two, because X represents the salaries of San Diego, Y represents the salaries of Salt Lake City. So I want to find the average of those, or I know the average of those is $47,449.50. All right, if I wanted to simplify this a little bit, let's get this fraction out of there. So I'm going to multiply both sides by 2. So then I just have X plus Y equals now 94,899. Just makes it a little bit easier to work with. Just X and Y, don't have any fraction or anything going on. Okay, so that's the first statement, allowed me to create one equation. The second one, the median salary in San Diego was $5,333 more than Salt Lake City. Okay, so it equals San Diego. San Diego's $5,300 more than Salt Lake City. So I could take 5,333 plus Salt Lake City, and that will give me San Diego. And if I wanted to set this up with all variables on one side, I could say X minus Y is 5,333. Okay, so from this now, I have two equations that I've created from that information they gave me. I have two variables, so two equations, two unknowns. I could set this up. So this first one, X plus Y, was 94,899. The other one's X minus Y equals 53,33. Two equations, two unknown. I already have them stacked. I'll add to eliminate. So that leaves me with just 2x on the left. The y's eliminate each other. X plus x is 2x. Add the numbers on the right, becomes 100,232. Divided by 2, x is going to be 50,116. All right, that is San Diego. Still need to figure out Salt Lake City. If I were to take this one, I know my X is 50,116 minus Y equals 5,333. If I wanted to subtract 5,333 from this side, but also add y to get it to the other side, I would end up with 44,783 would be y, and that's my Salt Lake City number. Okay, but again, it's just taking information from the problem, creating your equations, but that first step is creating variables, setting up variables. Okay, x represents this, y represents this. You could use a and b, you could use t and x, whatever, any letters you want to use. But you have to assign something, and that's what you're going to solve. Okay, one more. So this one's kind of small. I apologize for the font. You're just going to pull key information out of this. So the employees from maintenance go for coffee every day at 9 a.m. On Monday, Hector paid $4.85 for 3 cartons of milk. So right there, I'm going to create my variable M to represent milk. He paid $45 for 3 cartons of milk, 2 cups of coffee. So I know I'm going to variable C that I'm going to represent as my coffee. And 7 donuts. So that donuts, I'm going to say D represents donuts. On Tuesday, Guillermo paid $6.80 for 4 milks, 5 coffees, 8 donuts. Wednesday, Anna paid $5.30 for 2 milks, 5 coffees, and 6 donuts. What is the price of each? Okay, so each of those 3 statements had milk, coffee, and donuts in there. And they all equaled some number. So for the first one, for Hector, we could say $4.85 was represented by 3 milks, by 2 coffees, and 7 donuts. Second one was $6.80 was represented by 4 milks, 5 coffees, and 8 donuts. And then the last one, $5.30 was representative of 2 milks, 5 coffees, and 6 donuts. So now we have 3 equations with 3 unknowns. So this is what we were practicing with yesterday on how we could tackle this. All right. So I would probably look at, well, I could see this one here. If I group these 2, if I multiply this bottom one by a -2, that will give me opposite M. So I'm going to eliminate my M. You could choose whatever one you wanted to eliminate. We could have done a -1, and that would eliminate C. But then your second grouping of 2, you also want to look to eliminate C. Okay, so pick wherever you want to go. I'm going to eliminate M to begin with. And so I have the top remains unchanged. So 680 equals 4M plus 5C plus 8D. But now here on the bottom, if I do 1030, so that becomes a -1060 is going to be equal to a -4M, and then minus 10C, and then minus 12D. All right, and then I can add to eliminate. So this becomes a negative 3.8. The m's go away, which is what I want. This is a negative 5c and a negative 4d. Now I'm going to tackle these top two. And with these top two, I'm going to look to eliminate m, because I eliminated m from the first one. I want to make sure I eliminate m from the second one. All right. Well, this one's my only common multiple between 3 and 4 would be 12. So I'm going to multiply this whole top one by 4 and the whole bottom one by 3. And so this ends up being 19.4 equals 12m plus 8c. And actually, I want to do a negative. Let's do a negative 3 on the bottom one. We'll leave all these in this one positive. Plus 28d. And then my negative 3 becomes a negative 20.4 is going to be equal to a negative 12m, negative 15c, and negative 24d. Add to eliminate. This becomes a negative 1. My m's go away like I want them to. Negative 7c. And then plus 4d. All right, now I'm going to combine these together. And I'll say negative 1 equals 7c plus 4d. And negative 3.8 equals a negative 5c minus 4d. Conveniently there, my d's are opposite, so those ones already eliminate each other. I'm adding, so this is a negative 4.8. And then this would be 7 plus a negative 5. This should be a negative 7c. All right, that negative, I almost forgot that. So negative 7c plus a negative 5c is a negative 12c. Divide both sides by negative 12, I end up with c ends up being a positive 0.4. So this is all that work just to get one variable, but once you have that one variable, now you can start working with that. Okay, and so if I were to look at, let's put that in over here. So negative 3.8 is going to be equal to negative 5 times 0.4 minus 4d. Can solve for d, I end up with 0.45 equals d. All right, so I got the donuts, I got the coffee, and the last one, if I wanted to do the milk, let's do it with, I have to pick one that has all three variables now. I'll just choose this one right here. So 5.3 equals 2 times m, which is what I want to find. 5 times 0.4. And then plus 6 times 0.45. My only unknown is m. Work all this one out. Ends up being m ends up being 0.3. So for our final answer, what is the cost of each? Milk ends up being 30 cents. Donuts end up being 45 cents. And coffee ends up being 40 cents. But this is good practice again for these three equations with three unknowns. Take two, eliminate the same variable from your two groupings. Then you have a system of two equations with two unknowns. figure out one, and then start using that. Once you get the one variable, then you can start putting it into everything else. Okay, so in MathXL is part 3. Make sure that's a